taken from it, like a lot of stuff that we've done. So in this particular problem, and they give us a formula to start, is it growing or decaying? Growth by what percent? Every how often? Every 1 year, because it's t over 1 technically. Every 1 year. This says essentially which one of these is the same. This is in terms of yearly growth. This is in terms of, they want it in terms of monthly rate of growth. The population can be given by what? So what is, let's just analyze all four of these. Is this growth or decay? Growth by what percent? 1.2% every how often? This is t over 1 every year. Is that the same as 16% every 1 year? No, so that is not equivalent. This one, growth or decay? Growth by what percent? 1.2%. What does that mean? 12 times per year, right? Which means every how often? Every 1 month. Is that the same? Might be. Certainly could be, right? 16% every 1 year is going to be a much smaller percent on a monthly basis, right? But that's the frequency version of the formula. So that's 12 times per year, which you could convert mentally into every 1 month. So that has a chance. This one is growth or decay by 16%, 12 times a year again, right? 12 times a year would indicate, again, every 1 month. Is growing by 16% once a year the same as growing by 16% once a month? Absolutely not. That one's growing much faster. And then in 4, growth by 16% every how often? 12 years. Do you follow that? So the reason I like this one, this problem, so by process of elimination, it's absolutely 2. Every single one of these kind of reviews that growth by the percentage, every how often, or with the frequency. It puts in the frequency formula version of it versus the every 12 or every 12 years or every 1 year version of it. And then you kind of can just logically think through it. I don't know if I just had a thought here. If you wanted to see which one was the same version, you could type that into your calculator as y1, so 750 times 1.16 to the x power. And then what you think the right answer is, so if we're checking B, I'd also type in 750 times 1.012 to the 12x power. And if I looked at those two tables, they all have the same outputs, or pretty close to the same outputs. You know, the only reason it's not exact is because, truthfully, that's rounded. Let's just pretend that they wanted you to change that as an open response to a 1 month rate. Because right now it's 750 times 1.16 to the t over 1 year. If they wanted you to change it to a 1 month rate, you would have to plug in 1 month, right? The problem is these can't be in different units. So is it easier to change them both to months or both to years? Months, right? Because 1 year can easily be, so I'll do 1 month over 1 year is the equivalent of 12 months. And then if I just want to change this to a monthly rate, I would just do 1.16 to the 1/12th power. And it will give me a new base of 1.012. Do you see how they chopped off some of things? Right? It's technically 1.0124451, but they chopped off some of it. And now this is tricky, T over 1 month rate, except for, again, T was in years and month was in the denominator is in 1 month. So anytime you're asked to use this, you would just have to make sure your numerator is written in months. So if they said 5 years, you would have to change that T years to months. But so back to the table, 1.012 got chopped off. So when I look at the table, the numbers are very close for every input, like 1358 and 1329.6. They're going to be closer than any of these other options. If you compared them, they're only off because the decimal got chopped off. Okie doke. All right. So I already did this. I wasted space. And I already did this. Oh, that's the whole front page. Would you look at that? We're on the back. Okay, an object is slowing down such that its speed is decreasing exponentially. Ooh, this is the real beginning of the chapter. So we haven't seen a problem like this in a while. If after 2 seconds it's traveling 58 feet per second, and after 5 seconds it's traveling only 11 feet per second, then find an equation in this form. So we're writing the equation with 2 points. Exponential decay. So we've got a point at 258 and at 5 seconds 11. How do you write the equation of an exponential function with 2 points? What was the process? Who remembers? I think this is like day 2 of the chapter. Chris? Take a stab at it, Haley. That would be if it was y equals mx plus b. If you were writing a linear model, we can talk about slope. Exponentials, we can't talk about slope because it's not a straight line. It bends. Oh, yeah. Beautiful. xy, plug it in. So 58 equals a times b to the second power. Plug in the second point. So 11 equals a times b to the 5th power. Almost lining them up like elimination you would. But you don't add the equations. You don't subtract the equations. You divide. It's coming back slowly but surely. So 58 elevenths, whatever that would be. And here's the beauty. When you divide, a divided by a cancels. And this equals b to the negative 3rd. And how do we get rid of an exponential number? Raise it to the reciprocal. So to get that b all by itself, we're going to raise both sides to the reciprocal. So b equals 58 elevenths to the negative 1/3 power, which gives me 0.57. Crazy number. What's it tell me to write? Nearest 100. So 0.57. There's your b. Just like any other system, once you know b, go back to the easier of the 2 equations and solve for a. So I essentially need to divide both sides by 0.57 squared. So a will equal 58 divided by, if you want to keep it real exact, don't round the 0.57 in your follow-up calculation, divide it by that 0.57 squared, and you get 175.71. So now you write the equation. Y equals A times B to the x power. So what is my initial speed? 175.71. Is this growth or decay? Decay by 43% or whatever. Yes? So this brings us back. God, I have to look at the website. Definitely before Christmas, as this chapter was kind of exponentials in the first half, and then we learned about logs in the second half. And in a lot of ways, a lot of those earlier topics kind of were included all chapter long, but certainly there's something like this that we did and really haven't done much of since, just because it wasn't threaded through the rest of the chapter. So I'm just going to go back for you. On my website, the nice part about it is I don't need to do binder checks or anything, because my website has all of your notes and homework in order. So if you ever want to study for a test, you just go back. This one goes back to Intro to Exponential Function Basics, December 17th. So it's been almost a month. 3-week-long chapter, because obviously we had break. Yes? This one, very similar to the one that was on your quiz. If g of x is 22, I'm plugging 22, not in for x, but in for g of x. So 22 equals 1/5 to the 2x plus 7 minus 3. Reviewing or solving that should be review, right? Add 3 to both sides, log both sides, and go on. Number 4, why is 0 not in its domain? Georgia? Say it again. Nope. This is a log parent graph shifted how? Here's your log parent graph. How has it been shifted? Right 4. So there's a way to describe it using transformations. It's not the way I was initially thinking, but you could say x equals 0 isn't in the domain because, well, it initially was an asymptote, but now that it's been shifted right 4, it even more so won't reach an x of 0. You can't take the log of a negative is the easiest one. Because if you plug in, your explanation would be, because if you plug in 0, you'd be trying to take the log of -4, which you can't do. This one, very similar to what we just went over last night. How would you split up 40 if all you know is the log of 5 and the log of 2? How would you split up 40? 5 times 8, and then 8 is 2 to the 3rd power, right? Expand the multiplication into addition, bring your exponent of 3 out in front of its term, and then you can use the values that you know. Yes? Very similar to what we just did on last night's homework. And then here's a very present thing that we've just recently been doing. So really quickly, I will also say, this is a no-brainer. You have to know this formula, and you have to know how to use it. Anytime you see the word compound, it's a finance question. All of a sudden, in that type of question, an n comes into place. Right? If you compound monthly, n is 12. If you compound weekly, n is 52. And then if you see the word continuous, so if you see compound, you're going with this one. If you see the word continuous, you're going with the Hurt formula. P, by the way, could be here. Principal and lowercase a are the same thing. That's your starting value. Okay? So I don't know if I hit everything on my review sheets. I never know if I do. I just grab a sample of question. You should just look through those topics dating back to December 17th. Maybe just look at those homeworks and just kind of sift through and see if there's any problems that look foreign to you, and remind yourself via the notes or whatever how to do them. Okie doke? But those three formulas have to be memorized.